Hey everybody, glad to be back. Missing you all. I think what will work best here is if you guys have your ebooks open and you read the problem and then watch my video and then maybe pause my video to read the next problem. I'm kind of hoping that will work the best for us. In 10-1, extremely lucky Angela is getting money from her uncle to put toward college, and it says write out the amounts of the deposits for the first few months as an arithmetic sequence. Okay, so just to remind you from Math 1, sequences are numbers that are in a pattern with commas between them. What we're going to do is start with the number of terms, which is n. That's going to be the months, and then T of n is going to be the actual amount that is put in the bank. So in that month, how much was saved for her. Okay, so in month 1, he put $50 into a safe deposit box. So we have 1, and he put 50 in. And the month following, he had added 53. So in month 2, he had 53. He continued adding money like this, putting $3 more than he had the previous month. How much was added in the 12th month? Okay, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 56, 59, 62, 65, 68, 71, 74, 77, 80, 83, and it specifically said write it as a sequence, so I am putting the commas between. So month 12, he deposited $83. Okay, work with your team to write a formula for the arithmetic sequence that determines the amount deposited by the nth month. Check that when n equals 1, representing the first month, your formula gives you $50. Using your formula, determine the amount of the final deposit on the last month of the 18th year. Okay, so to remind you guys, the equation is kind of y equals mx plus b form, so it's, oh no, I need my whiteout already. T of n equals growth times n plus the 0th term. Okay, and blast from the past, we call this the explicit equation. So in this case, you have T of n equals, the growth is $3 each month, plus the 0th term. So let's look up here. The 0th term would come before the first month, so that would be month 0, which would be 47, down 3 from 50. And using your formula, determine the amount of the final deposit on the last month of the 18th year. Okay, so in the final month of the 18th year, we know that if she's 18 years old and there's 12 months in a year, that would be month 216. So I am going to find month 216, and I'm going to use that to plug into my equation. So the term at 216 is 3 times 216 plus 47, plugging that in, and so that final month of her 18th year, he would have deposited $695. I want to make sure that you guys understand this is the deposit he made that month. That's not how much she would have in the bank. She would have all of this saved up, and on that last month he would have put $700 in almost, which is a lot for a person to put in an account for a month. Again, stressing how lucky Angela is. I never had an Uncle Zachary. You guys miss me. Okay. Now, number 2. Angela continued to think about Uncle Zachary's savings. Uncle Zachary wrote his equation as T of n equals 3 times n minus 1 plus 50. Verify that this equation is equivalent to the equation your team wrote for problem 10.1 and represents the same sequence. What's the advantage of writing the equation as Angela did? What's the advantage of writing it as Uncle Zachary did? Okay, so this is Uncle Zachary's equation, this is Angela's equation, so the one we wrote, and Uncle Zachary's is the same because if you distribute this, you get the same equation. Okay, what are the advantages? Okay, so we're not going to write Angela and we're not going to write Uncle Zachary. What we're going to write is in terms of n or in terms of n minus 1. Okay, what are the advantages of writing it in terms of n? Well, it looks linear. You can see the growth easily. Easy to plug into. What are the advantages of writing the equation in Uncle Zachary's way? Really, it's also linear. It's not as easy to see. You can see the growth easily. But the major advantage of Uncle Zachary's form is that you don't have to find the 47. You don't have to worry about going backwards to the 0th term. You can just use the first term. So uses first term instead of 0th, which is great, especially for those of you back in Math 1 who always forgot to find the 0th term. You know who you are. Okay, B. Determine the amount of money in Angela's college fund at the time of her first birthday after Uncle Zachary had made exactly 12 deposits. Okay, so they want us to add all of this business up. 50 plus 53 plus 56 plus ... plus 83. And we are going to cheat a tiny. Because we can. And we are going to look that up. That is $798. Feel free to verify that on your own if you like. Do you guys notice that I have switched the commas to plus signs? And this is representing now adding up everything instead of just listing. Okay. Getting back to the problem. Angela wonders how much money had been saved by her 5th birthday. Can you think of ways you might be able to figure this out without having to add the amounts for each month? You do not need to actually make the calculation. Be ready to share your ideas with the class. Well, I'm going to give you a cool story about Gauss. And so the cool story will help you guys with number 3. By the way, we are going to stop at number 3. I know the assignment sheet says to number 4, but number 4 is kind of long. If I make a video for that, probably won't upload, and I can fit everything I need to teach into numbers 1, 2, and 3. Okay, so there was this mathematician named Gauss. I don't even know the time. I would look it up if I was at school and I had my book, but he was a very, very naughty little child. Think about like Bart Simpson type. Super, super smart though. So one day his teacher asked him to add up all the numbers between 1 and 100 because the teacher thought that that would occupy his time for a while and the teacher could get a break from him. Unfortunately, Gauss, being so smart, came up with a formula on how to do that, and so I'm going to show you what Gauss did, and then we're going to use it to find out how much money Angela has. Okay, so first we want to define an arithmetic series. And an arithmetic series is the sum of the numbers in an arithmetic sequence. Okay, so we have already worked with this. You guys just didn't know it was called a series. Scrolling up, this is a sequence because it is separated by commas, and this is a series for that same sequence, which is separated by addition signs and actually has an answer of $798. Okay, now let's talk about Gauss. So Gauss, he was this really precocious kid, as I told you, super smart. And so the teacher gave him a scroll, papyrus, chalkboard, don't know what it was at the time. Probably not stone. Okay, anyway. And the teacher told him to add up the numbers 1 through 100. So let me show you what Gauss did. He came up with this in about 2 seconds, by the way. Okay, so first thing he did was write the numbers 1 through 100. He didn't write them all because he's too smart for that. Forwards and backwards. And then he added up each column and noticed that they all added to the same number. Okay, now you have a series of 101s here, so you have a list of 101s. So the sum is all of these 101s. How many of these are there? Well, there's a list of 100, so there's 100 101s, and he has to divide that by 2 because he wrote the list twice. So he said, okay, just add up the columns. There's 100 of those columns, but I need to divide by 2 because I wrote the series twice. Amazing kid, right? Okay, so this gives us a formula. So sum equals n over 2. Okay, so this is the n, which is the 100. That's how many numbers there are. And then over 2, and t of 1 plus t of n. Okay, so this is the first number, which is 1. This is the last number, which is 100. 1 plus 100 gives us 101s, so there's that, times the number of numbers there are, which is 100, divided by 2. Okay, so we're going to make little arrows. Number of terms, first number, last number. Okay, so this is how we can cheat isn't the best word. Cheat isn't a great word, but we can use this super efficient formula to find the sum of any arithmetic series without having to sit and go on the calculator 50 plus 53 plus 56 plus blah blah blah. Okay, so what we're going to do is find the sum of what Angela has after her 18 years. So, and I'm fitting this, people. Okay, so how many months were there? If I scroll back up here, there were 216 months in her 18 years, divided by 2. Okay, what was the first amount that she got? $50. What was the last amount that she got on her 18th last month of her 18th year was $695. So I have number of months over 2, first amount she got, last amount she got, and her total is an amazing $80,460, which will almost pay for 4 years at a CSU. I know this is not exactly what 10-3 was, but I'm trying to condense this all a bit for video length. If you guys could please copy this down onto paper, do the homework, which I believe is 7 through 13, and post that by Sunday. That's not true, Monday, because you guys would have had the weekend to do it. That would be amazing. Miss you all again. I'll post another video with the next classwork, and see you guys soon.